Next property we will discuss is about dehydration of alcohols. Dehydration of alcohols means removal of water molecule. I'm going to write the reactions here. This is a primary alcohol. It's heated with concentrated sulfuric acid at 443 Kelvin. And I am taking a secondary alcohol. Here 85% phosphoric acid at 440 Kelvin. The next I am taking tertiary alcohol. This is treated with 20% phosphoric acid at 368 Kelvin. Okay. So, dehydration of alcohol, from the alpha carbon atom OH will go and from the beta carbon atom hydrogen is eliminated. So, it is also a beta elimination. So, what will be the product? So, getting CH2 double bond CH2 plus H2, that means we are getting an alkene. Now, here also you see, this is the alpha carbon, this is beta and this is also beta. So, OH will go from alpha carbon and hydrogen from beta. Now, both the beta carbon is having same number of hydrogen atom. So, it does not make any difference. So, we will get CH3, CH double bond CH2 plus H2. Then here also this is the alpha carbon, this is beta, beta, beta. So, we will get CH3, CCH3 double bond CH2. Now, listen here. When there is more than one type of beta carbon having different number of hydrogen atom, always the hydrogen will be eliminated from which carbon? The carbon which carries less number of hydrogen atom. That is, according to Seitzev's rule, more alkylated alkenes are stable. So, that same what you have studied in haloalkenes, the same rule is applicable here also. Now, see, in all these three cases you see, first case I took a primary alcohol, in the second case I have taken a secondary alcohol and in the third case a tertiary alcohol. But as the type of alcohol changes, what is happening to the reagent which you have taken? It is different. In case of primary alcohol, we are taking the strongest dehydrating agent, that is concentrated sulfuric acid. In case of secondary alcohol, it is 85% phosphoric acid which is mild and the temperature is also low, and in case of tertiary again it is just 20% phosphoric acid at what, 368 Kelvin. So, how can you explain this? Why is the difference in the catalyst which you are taking is differing in all the three different types of alcohols? Now, see, in case of a primary alcohol, there is only how many electron releasing groups? 1. Here how many are there? 2. Here how many are there? 3. So, due to the presence of this electron releasing group, what happens to the electron density on the carbon atom carrying oxygen atom? It increases. So, what will happen to the cleavage of the carbon oxygen bond? It becomes easy. So, in case of tertiary, how many electron releasing groups are there? 3. So, the electron density of the carbon atom increases. So, the bond cleavage between carbon and oxygen becomes easy. So, the reagent which you require is what? Mild. In case of secondary, how many are there? Only 2 electron releasing alkyl groups. And in case of primary, only what? How many? 1. Or you can say a tertiary carbocation is more stable than secondary, which is more stable than what? Primary. So, it is explained on the basis of stability of the carbocation formed. A tertiary carbocation is more stable than secondary, which is more stable than primary. So, that is the reason why in case of tertiary alcohol, you require a mild dehydrating agent, and in case of primary, you require what? A very strong dehydrating agent, that is concentrated sulfuric acids. Is it clear? So, alcohols on dehydration you get alkenes, same way haloalkenes on dehydrohalogenation also you get what? Alkenes. So, we are preparing alcohols from alkenes. So, from alcohol when water is eliminated you get what? An alkene, and tertiary alcohol undergoes dehydration faster than secondary, which undergoes faster than what? Primary, and this difference is explained on the basis of stability of the carbocation formed. A tertiary carbocation is the most stable and the least stable one is which one? Primary. So, is it clear? So, alcohols on dehydration gives you alkene. Next we will go to is the mechanism of dehydration of alcohol to give alkene. So, you will get question like this. Give the mechanism, in general they can ask, give the mechanism for the dehydration of an alcohol to give an alkene, or they may give you the reaction and they may ask you to propose the mechanism. So, this I am just showing you. Propose mechanism for the reaction CH3 CH2OH concentrated H2SO4 440 Kelvin, sorry 443 Kelvin gives CH2 double bond CH2 plus H2O. Okay, so for this you have to propose a mechanism. So the first step is what? Sulfuric acid will give what? H plus. So first step is H2SO4 aqueous dissociates to give you H plus plus HSO4 minus. So you get what? CH3 CH2, here oxygen is having what? Lone pair of electron, so the proton will attack oxygen atom. So first step is what? Protonation of alcohol. Okay, so what are you going to get? CH3 CH2 OH2 positive charge, that is a protonated alcohol you are getting. Okay, next step is formation of, do you have any more reagent left? Nothing is there? Formation of carbocation. How is a carbocation formed? You see here. Now, when you take carbon and oxygen, which is more electronegative oxygen, so this electron pair will shift here, resulting in the formation of what? Carbocation. So that's how I said you stability of the carbocation. So here what type of carbocation is formed? A primary carbocation you have got. Next is deprotonation. Now is the carbocation stable? Because this carbon is having only how many valences? 3. Deprotonation. See here. This carbon is having positive charge. So deprotonation means removal of a proton. So any one of the hydrogen from the carbon adjacent to the carbon which carries positive charge. It cannot be eliminated from the proton, cannot be eliminated from this carbon by already this carbon is deficient of what? Electron. So from the adjacent carbon a proton is eliminated and the sigma bond shifts here. So what are you going to get? CH2 double bond CH2 plus H plus. So this will go and react with what? Acid to give back what? Sulfuric acid. So sulfuric acid is just acting as a catalyst to give what? A proton. So understood? So the first step is protonation of alcohol. So you are getting a protonated alcohol. While teaching the chemical properties of alcohols, I told you know, when alcohol, protonated alcohol acts as an electrophile, and during that time which bond cleavage is happening? Carbon oxygen. So got it? So here carbon oxygen bond cleavage is taking place to form what? A carbocation. Then the carbocation loses a proton to give you what? Alkene. So this is the mechanism of dehydration of alcohol to give alkene. So the same another thing property also will be studying in ethers. Dehydration of alcohol can give also what? Ether. Alcohols and dehydration gives you ether. Alcohol and dehydration gives you what? Alkene also. So the difference is the amount of alcohol which you take will be different. So this is the mechanism. So here it's dehydration of alcohol to give you what? Alkene. Next is oxidation of alcohol. So there are 3 different classes of alcohols: primary, secondary and tertiary. And the strong oxidizing agents which we are going to use is KMnO4 in presence of acid or alkali, then potassium dichromate in presence of acid. Even concentrated HNO3 also you can use. So all these are what? Very strong oxidizing agents. So first I am going to take a primary alcohol, CH3 CH2 OH. This is an oxidation with any one of this reagent, KMnO4 in presence of acid. Primary alcohol is oxidized. What will you get? Already we have studied aldehydes and reduction. You are getting which alcohol? Primary alcohol. So primary alcohol on oxidation will get what? Aldehyde. So you are getting CH3 CHO. Now see the number of carbon atom. The alcohol is having 2 carbon atom. Aldehyde is also having how many carbon atom? 2 carbon atom. This reaction doesn't stop here. It's because KMnO4 is a very strong oxidizing agent. So CHO is converted into COOH. So what can you say? A primary alcohol is oxidized to a carboxylic acid. Now see the number of carbon atom in the primary alcohol, 2. The acid is also having how many carbon atom? 2. So what can you conclude? Primary alcohol on oxidation with strong oxidizing agent like KMNO4 or dichromate in presence of acid or alkali, or even if you use concentrated HNO3, is converted into a carboxylic acid with same number of carbon atom. Instead of potassium dichromate, you may be given also chromic acid H2CrO4. That is, dichromate reacts with the acid to give you what? Chromic acid. So is it clear? A primary alcohol on oxidation with any of this reagent gives you a carboxylic acid with what? Same number of carbon atom. So that is the first one for primary alcohol. So primary alcohol on oxidation with strong oxidizing agent gives acid with same number of carbon atom. Okay. Next we will see secondary alcohol. Okay, this I have taken. This is on oxidation. Here also I am going to take KMNO4 in presence of acid. Here you see again ketones on reduction you are getting what? Secondary alcohol. So a secondary alcohol on oxidation you will get what? Ketone. So CHOH is converted to what? A ketone, that is removal of hydrogen. So you will get CH3, C double bond O, CH2, CH3. Now see the number of carbon atoms, 1, 2, 3, 4. Here also how many carbon atoms? 1, 2, 3, 4. So what can you say? A secondary alcohol on oxidation you get a ketone with same number of carbon atom. Now this on oxidation you see. Now here you see the bond cleavage can take place either here or here. So one thing you keep in mind, that is why I have taken an unsymmetrical ketone alcohol. It is based upon a rule known as Popov's rule. What is Popov's rule? The keto group will always remain with that alkyl group which is small in size. Is it clear? So during oxidation of an unsymmetrical ketone, the keto part will always remain with the alkyl group which is small in size. So here the CO will remain with what? CH3. Is it clear? So it is converted into what? CH3 COOH plus. Then this will also undergo CH2 is always converted to COOH. So I will get what? CH3 COOH. So from this what can you conclude? Secondary alcohol on oxidation, you get a ketone with same number of carbon atom which on further oxidation gives an acid with what? Less number of carbon atom. Is it clear? You are getting an acid with less number of carbon atom. And in case of unsymmetrical ketones, the keto part will always remain with that alkyl group which is small in size. So the cleavage will take place in such a way only. So here, see here, this alkyl is bigger in size and this is small in size. So the CO will remain with this. So the bond cleavage is taking place where? It will take place here. So what will be the product? CH3, COH, and this is oxidized to CH2 is converted to COOH. If you take acetone isopropyl alcohol, this is an oxidation. Instead of KMNO4 I am taking dichromate H plus, what will you get? CH3, C double bond O, CH3. This is again further on oxidation with the same reagent. So if it remains with this or this, will it make any difference? It does not make any difference. So anyway you can take, because both are having what? Same alkyl group. This on the left side also you have methyl, on the right side also you have methyl. So what will be the product? CH3 COOH, and CH3 is converted to carbon dioxide and water. So is it clear? So a primary alcohol on oxidation you get an acid with same number of carbon atom. A secondary alcohol on oxidation we get what? Acid with less number of carbon atom. Is it clear? and these reactions cannot be used for conversion to convert an alcohol to an aldehyde or an alcohol to a ketone. Why? The reaction will not stop with the formation of aldehyde or ketone. The reaction will stop only after the formation of what? Carboxylic acid. Because the KMnO4 and dichromate are what? Very strong oxidizing agents. So is it clear? So in this cases, the reaction won't stop with the formation of aldehyde or ketone. It will stop only with the formation of acid. So wherever you have to convert an alcohol to a carboxylic acid, you can use this reaction either with same carbon atom or with less number of carbon atom, because primary alcohol will give an acid with same number of carbon atom and secondary alcohol will give an acid with less number of carbon atom. And tertiary alcohol does not undergo oxidation with this reagent. For that you have to use concentrated HNO3, and that it is first converted into an alkene, then the alkene is being converted into what? Ketone, and then it undergoes oxidation to acid. So that part is not there in for you to study. Now see here, if you want to convert an alcohol to an aldehyde without converting it into acid, then you have to use oxidizing agents which are very mild. Now see here, CH3CHO, this is an oxidation with chromic anhydride, CrO3, CH. See, primary alcohol CH3CH2OH, this is on oxidation with mild oxidizing agent like chromic anhydride, then CH2OH is converted to what? Aldehyde, and the reaction will stop here. This is not further undergoing what? Oxidation, because this is a mild oxidizing agent. Same way, alcohol also will be, secondary alcohol will be converted to what? Ketone. You get CH3, C double bond O, CH3. Okay. Now, if you have an unsaturated aldehyde, see here. Now, if you use a unsaturated alcohol, primary alcohol, if you use a KMnO4, what will happen? Double bond also will be what? Undergoing oxidation, because it is a very strong oxidizing agent. For this, you can use a reagent called pyridinium chlorochromate. Its formula is C6H5NH plus ClCrO3. This is pyridinium chlorochromate. So you can directly write it as PCC. So this will oxidize only the alcohol part. It will not affect what? The double bond. So what are you going to get? CH3, CH, double bond, CH, CHO. That is, unsaturated alcohols are converted into aldehydes, unsaturated aldehyde by using what? PCC. Same way, ketones also can be converted to what? Secondary alcohols also can be converted to ketones by using what? Pyridinium chlorochromate. If it is unsaturated, the double bond won't be attacked. So PCC is a very good reagent for converting primary alcohol as well as secondary alcohol to aldehyde and ketone, because it is a very mild oxidizing agent and it will not affect the double bond or triple bond, because they cannot oxidize, because the oxidizing agents are what? It is very mild. Next is dehydrogenation reaction. Now I am going to write all the three classes of alcohol. CH3, CH2OH is a primary alcohol, or I will take another one, CH3, CH2, CH2, propane 1 on. This I am going to heat with copper at 573 Kelvin. Then second I am going to take a secondary alcohol, CH3. This also is heated with copper at 573 Kelvin. Then a tertiary alcohol, this is also heated with copper at 573 Kelvin. Now dehydrogenation means what? Removal of a molecule of hydrogen. And see, one hydrogen atom will go from the functional OH, another will go from the alpha carbon. So what will be the product? CH3, CH2, CHO plus H2. Is it clear? Here which hydrogen is eliminated? Till now whatever we studied, the hydrogen atom was eliminated from which carbon atom? Beta carbon atom. Here the hydrogen atom is eliminated from which carbon atom? Alpha carbon atom. So this is also known as what? Alpha elimination. So last year you had studied about both beta elimination and alpha elimination. So here the hydrogen atom is eliminated from which carbon atom? Alpha carbon atom. One hydrogen is going from the functional group, another one is going out from the alpha carbon atom. So we call it also as what? Alpha elimination. So primary alcohol when heated with copper at 573 Kelvin, what are you getting? You are getting an aldehyde. Now let us see here. Again this is the alpha carbon. So this hydrogen and this hydrogen will go. So what will be the product? CH3, C double bond O, CH2, CH3 plus H2. That means you are getting a ketone. So primary alcohol gives you aldehyde and secondary alcohol is giving you ketone. Now let us come to the tertiary alcohol. Now here is alpha elimination possible? This is the alpha carbon. The alpha carbon, does it have any hydrogen atom? It does not have hydrogen atom. So in case of tertiary alcohol, when heated with copper at 573 Kelvin, it does not undergo dehydrogenation reaction, but it undergoes dehydration reaction. It undergoes dehydration reaction due to the absence of alpha hydrogen atom. So is it clear? That is, tertiary alcohol when heated at with copper at 573 Kelvin, instead of undergoing dehydrogenation reaction, it undergoes what reaction? Dehydration reaction due to the non-availability of hydrogen atom in the alpha carbon atom. So here it is undergoing what reaction? It undergoes beta elimination reaction. It undergoes beta elimination reaction. That means from the alpha carbon atom OH goes, and this is beta carbon. This is also beta carbon, this is also beta carbon. So from the beta carbon atom, hydrogen will be eliminated. So what will be the product? CH3, CCH3, double bond, CH2 plus H2O. That means you are getting what? What is the name of this common name? Isobutylene. So is it clear? Only primary alcohol and secondary alcohol when heated with copper at 573 undergoes alpha elimination or dehydrogenation reaction to give you aldehyde and ketone. But a tertiary alcohol does not undergo dehydrogenation reaction due to the absence of alpha hydrogen atom. They undergo what reaction? They undergo dehydration reaction due to the absence of what? Alpha hydrogen atom. So dehydration means it's what? A beta elimination reaction, and what is the product? You are getting an alkene. Next we'll study is chemical properties of phenol. Now see here, phenol when heated with zinc dust. Phenol when heated with zinc dust, you get benzene plus zinc oxide, and it's a very important reaction for conversions. Phenol can be converted to toluene, phenol can be converted to acetophenone, phenol can be converted to chlorobenzene. Phenol, because phenol first when heated with zinc dust gives you benzene, benzene can be converted to any haloarine, then benzene can be converted to alkyl benzene by Friedel-Crafts reaction. Benzene can be converted to what? A ketone by Friedel-Crafts acylation reaction. So it's a very important reaction for conversions. Now see here, phenol when exposed to sunlight, I told you what? Phenol is what? A colorless liquid, but when exposed to air or sunlight, it undergoes oxidation to give you what? Quinone. That is, it becomes brown in color. Same way, phenol on oxidation with sodium dichromate or potassium dichromate in presence of acid, it is converted into a diketone. This is the diketone, that is benzoquinone. Okay. So phenol when heated with zinc dust gives you benzene, and when oxidized with dichromate in presence of an acid, you get a diketone which is known as benzoquinone. Now next is electrophilic substitution reaction in phenol. Now already we have discussed, that is, in case of phenol, oxygen is having lone pair of electron. So due to resonance, the electron density increases in which position? Ortho and para position. So in case of phenol, electrophilic substitution reaction takes place in which position? Ortho and para position. It is due to what? The plus R effect or plus resonance effect. the first one we'll go through is bromination. Now listen carefully, here you get few reasoning questions. Now phenol when treated with aqueous bromine, here I am writing one reaction, and then phenol when treated with bromine in presence of carbon disulfide. Now we have discussed already the electrophilic substitution reaction in chlorohalorine also. Now see here, chlorobenzene when treated with chlorine in presence of what? Halogen carrier. Then only it is undergoing what? Electrophilic substitution reaction. Here you see in this case I have just used aqueous bromine, and here I have used bromine in presence of carbon disulfide. In both the cases there is no halogen carrier. Now when it is in aqueous bromine, you see already we discussed phenol is what? A very strong acid. So when it is in aqueous state, phenol will be converted to what? Phenoxide ion. It will be converted to phenoxide ion, and this extra electron is involved in what? Resonance. So due to resonance the electron density is increasing in what? There is high electron density in the ortho and para position, which is enough for polarization of bromine molecule. That is, this gives electron, this bond shifts here, so this bromine is getting what charge? Positive charge, and it can easily attack here because here the electron density is what? Very high. Is it clear? So that is the reason why halogen carrier is not required. Why? Because in aqueous state phenol dissociates to give you what? Phenoxide ion, and the extra electron is involved in resonance, due to which the electron density increases in ortho and para position, and that electron is enough for polarization of what? Bromine atom, that is for the production of bromonium ion. So here halogen carrier is not there, and since the electron density is very high in all the three positions, you get a tri-substituted product. So you are getting 2,4,6 trinitro, 2,4,6 trinitrophenol. So is it clear? That is phenol when treated with aqueous bromine, you get 2,4,6 trinitrophenol. Now when phenol is treated with bromine in presence of carbon disulfide, here if it is not in aqueous state, so you are not going to get what? Phenoxide ion. But here also what happens? The lone pair of electron is involved in resonance, and therefore the electron density increases in what? Ortho and para position, but the density of electron is what? Less compared to what? Phenoxide ion. So the attack will take place in which position? Ortho and para. So there also the electron density at ortho and para position is enough for polarization of what? Bromine atom. So you are getting orthobromophenol and parabromophenol. Is it clear? In case of aqueous state, phenoxide ion is produced, that is involved in resonance, due to which the electron density in the ortho and para position becomes very high, and therefore the attack takes place in all the three positions, and that electron is enough for the production of bromonium ion. So you do not require a halogen carrier. In case of phenol when treated with bromine in presence of carbon disulfide, here phenoxide ion you are not getting, but the electron density is increasing in which position? Ortho and para position, but compared to phenoxide ion the electron density is less, but that electron density is enough for production of what? Bromonium ion. So you do not require what? A halogen carrier. So you are getting orthobromophenol and parabromophenol. Now when phenol is treated with dilute HNO3, so mild agent only, so you get orthonitrophenol and paranitrophenol. Now when this is treated with, phenol is treated with concentrated HNO3 and concentrated sulfuric acid, you get 2,4,6 trinitrophenol, which is known as picric acid. But nowadays picric acid is prepared how, you know? First this is treated with concentrated sulfuric acid and you get SO3H, SO3H, that is phenol 1,2 disulfonic acid. This is then treated with concentrated HNO3 and it is being replaced by nitronium ion. So, you are getting 2,4,6 trinitro phenol, or this is also known as what? Picric acid. Is it clear? So, all these reactions are important. So, phenol can be converted to what? Picric acid. So, earlier directly we are writing concentrated sulfuric acid and concentrated HNO3, that is nitrating agent, and you directly get that. But first it is converted to what? Phenol 1,2 disulfonic acid using concentrated sulfuric acid, then it reacts with concentrated HNO3 to give you what? Picric acid. So, these are the examples for electrophilic substitution reaction in phenol. It is taking place in ortho and para position due to what? Plus resonance effect. So, is it clear? The chemical properties of phenol. So, in the next class 2 reactions are left, that is Kolb's reaction and Riemann-Timan reaction, and then we will discuss preparation and properties of ether.